Quickly here, we're going to talk about parallel and perpendicular lines. So what we need to understand with parallel and perpendicular lines are there are a few things that we can look at with the slopes that actually help us define these things. First of all, parallel lines have the same slope. If we think about that, a parallel line goes up to the right. Then if a line was parallel to it, it would also need to go up to the right. Both lines never are going to touch. They're never going to meet. That's the definition of parallel. So what that means is they have to go up by the same amount and over by the same amount every time. If they don't go up by the same amount and over by the same amount, they're eventually going to meet and they're not actually parallel. So they're going to have different y-intercepts and they have to have the same slope. The reason their y-intercepts are different is because they're never going to meet. If one goes through a y-intercept of say 4, the other one can't. Otherwise, they wouldn't be parallel lines. They would be intersecting lines. Perpendicular lines have a slope what's called a negative reciprocal. Now what we have to look at, and I'll show you with two examples. First, if we have a vertical line and a horizontal line, well, perpendicular means that they meet at a 90 degree. We know the slope of a vertical line is 1 over 0, or it could be a billion over 0, but it's at least 1 over 0. And we know the slope of a horizontal line is 0 over 1. Well, if I made that negative 0 over 1, it's not actually going to make any difference because negative 0 is the same thing as positive 0. But if we look at another example where we have a line that's, say, going like this, well, let's say positive 1 or positive 2. Let's call that positive 2. Well, to go like this and make a 90 degree angle, this needs to be at least a negative because it's going down to the right, and it's actually negative and we're switching it. This was 2 over 1, that's going to be negative 1 over 2. We're switching the entire slope. We're doing what's called the negative reciprocal. To create a negative reciprocal, we're at the bottom now, you flip the fraction and change the sign. So what perpendicular lines have slopes that are negative reciprocals, and the y-intercept can be the same or different. It's the same if they intersect right at the same point. It's different if they don't. Remember, horizontal lines are parallel. So if we have two horizontal lines, they're parallel and have a slope of 0. Vertical lines that are parallel would have a slope that is undefined. A horizontal line and a vertical line are perpendicular to one another. We just talked about that. Even though 0 can't be negative, we can think of it as being negative, just the way they interact. So if I were to state a line that's perpendicular to 3 over 4, state the equation, or an equation that is perpendicular to 3x minus 4. All we have to do is look at our slope is 3. So the perpendicular slope, 3 is equal to 3 over 1, is negative 1 over 3. And we can use any b value we want. So we can say something therefore y equals negative 1 over 3x, and we'll say plus 4 is perpendicular. All right. We could also state an equation that is parallel to the following line and passes through this point. Now we're going to learn how to use this kind of method soon, but if it's parallel, so we've got our slope is equal to negative 2, a parallel slope is also equal to negative 2. And now we know that all of our points are always given in xy. Well, this point is 2, negative 3. And we know the equation of a line is y equals mx plus b. We know our m. We know x and y, so we can find b, and then we can state our equation. So we can sub in negative 3 equals negative 2 times 2 plus b. Negative 3 equals negative 4 plus b. Move that negative 4 to the left. It's going to become positive. We're going to get 1 equals b. Therefore, now we've got our b value. We've got our slope. y equals negative 2x plus 1 is the equation. Okay, and we're going to work on that more in a little bit. Here are a couple of questions for this.